So here, good morning, grade 11 students. In this session, we're going to continue about our lesson about the pedigree in week 27. So in this session, we are going to determine the pedigree. What is the pedigree? We said that it's a genetic representation of the family tree. This family tree, it represents the inheritance of some traits or some diseases that are spread over several generations. It shows the relationship between the members of this pedigree and indicates if they carry the allele or they carry it silently or they express it in this pedigree. So in this pedigree, we have the family tree, the family members. We said that the first one, we said that it's called the first generation, generation one. So this is the first generation. This is the second generation. This is the third. I'm always. They should be in Roman number. And this is the fourth generation. So these are the four generations in this pedigree. Maybe you're going to put one, two, three, or one, two, three, four, and so on. Sometimes what happens? Sometimes they put numbers as one, two, then three, four, five, six, seven, 8, 9, 10, and so on. So here it's easier for you. You can say individual 10 or individual 2 without mentioning even the generation. It works because you have different numbers. But if they mention, for example, 1, 2 here, and then here they mention and 1, 2, 3, and so on. So here you can know that this is the you have to use the generation. You have to use, for example, generation 1 and generation 2 and generation 3 and 4 as well. So in this session, if you want to use this generations, so I have used to mention this the name of this individual. I can't say one because here I have one, here I have one. So I have to mention the generation. So 1 dash 1, individual 1 1, generation 1, individual number 1 of generation 1. Here, individual 1 of generation 1 and individual 1, individual 2, sorry, of generation 1. This one. Here, number 1 is 2 1, and here it's 2 2, 2 3, and so on. Okay, this is related to the naming of them. Before we move to the application, last time we talked about the Sarah and Maher. They are normal, both of them, and they have a family history of albinism. We said that albinism is a disease where melanin is not produced. This leads to the lack of pigmentation of the hair and the skin cells as well. So this is the albino individual. Whenever an individual has albinism, it's called an albino individual. So this individual has lack of pigmentation. So here it's the albino individual. Whenever you have albino, you have having albinism. So Sarah and Maher, they gave birth to 4 children, Ahmad, Jack, Marie, and Fatima. All of them, they are normal, except for Jack, which turned out to be an albino. And Ahmad, Marie, and Fatima, all of them, they are normal. So meaning that we have 3 out of 4 individuals, they are normal. However, we have only 1 out of 4 which is affected or albino. So here we are going to verify these results later on. So this application, they need to construct the family tree and then determine the dominant and the recessive, designate by symbol each of the corresponding alleles, determine the possible genotype of the parent and their children, and we have to perform the essential factor analysis to verify the results, meaning that you have to say at the end, therefore, the results are verified. So here we have, in this note, we have the marriage, the relative meeting, children, twins, and we have the symbol of the fetus. So here we have this pedigree. This pedigree is showing the family members. Maher and Sarah, they are normal. They gave birth to affected individuals, Jack, and to normal individuals, Fatima, Ahmad, and Marie. So here you have to know that we have different genotypes in this pedigree. First of all, Maher and Sarah, they are normal, but they gave birth to Jack, which is an affected individual. It's an albino. So the allele of the disease, it was masked in the parents. It's recessive with respect to the normal dominant allele. So here, when I say A, it should be homozygous and recessive. AA. So if AA, homozygous and recessive. So Maher and Sarah, they are normal. So sure, they have the allele of the normal N. Here they have the allele N. But here Jack should inherit A from each of his parents. So the Maher and Sarah, they should be NA and A. They should be heterozygous. Marie, Fatima, and Ahmed, they are normal. So they carry the allele N. So you have the N capital allele. Okay? Whether they are the homozygous or heterozygous, we can determine this later on. Yes, Hassan?
أستاذ ما فهمت ليه هو عنده AA.
ليه عنده AA allele of the disease first of all. Maher and Sarah, they are normal. خليك معي. Okay? So Maher and Sarah, they are normal. تمام؟ They gave birth to affected individual, Jack. صح؟ So allele of the disease is allele of the disease is dominant or recessive هون؟ recessive. ما كان مبين بالبارنتس بس بين بابنهم. So the allele of disease is recessive. هلا هون مش لازم انا اطلع genotype قبل ما اقول مين dominant مين recessive. بس already لانه حليناها last time. Okay? So هون Jack هو affected. So it should be homozygous and recessive. It should be AA. So إذا هو AA حيجيب A من maternal و A من paternal. So A من بيو A من أمه. So إجباري Maher and Sarah they should be heterozygous having the genotype and A. Okay, Hassan?
ماشي.
Oh, okay, great. So Ahmad, Fatima, and Marie, all of them, they are normal. كلهم they are normal. Okay? So they have the allele N. But the second allele, it can be an N or it can be an A. We can't determine this unless with special techniques, we're going to know about them in the coming sessions, or with the marriage of these individuals. If Fatima married, for example, or Marie married, or Ahmad married, and they gave birth to an affected individual, 100% they will be an A. But here, till now, we don't know if they are an A or an N. So moving to the first part, determine the dominant and recessive allele. Since Maher and Sarah Ahmad, they are normal, and they gave birth to an albino Jack. So the parents must be carrying the allele of the albinism, but it is masked, Yahsan, by the dominant normal allele. So they carry the allele of the disease, but it was masked. And it's a very important word, masked in the parents by the normal dominant allele. So the normal allele is dominant over the allele of albinism, which is recessive. Symbols always dominant capital with recessive small. So let M capital be the symbol. Normal allele, which is dominant over the recessive allele of albinism. We let A small be the symbol of the allele of albinism, which is recessive with respect to the normal dominant allele. Part 4, they said determine the genotype of each of the individuals in this pedigree. First, we'll start with Jack. Jack is affected, is an albino individual. So the allele of the disease here is recessive, and it should be only expressed in the case of homozygous. So 100% Jack should be A small, A small. While moving for the second one, Maher and Sarah, they are normal, but they gave birth to an albino Jack. So they should be carrying the albinism allele, but it was masked. So their genotype should be hybrid, and 100% should be NA, and it's heterozygous. While Marie, Fatima, and Ahmad, they are normal, but we can't know if their genotype is pure, an N, or hybrid, an A. So it can be an N or an A. That's why we can't determine this unless we have a special technique. Then we move to perform the essential factorial analysis. Always in the factorial analysis, we start with the phenotype. So the phenotype, both of them, they are normal. The male and the female, they are normal. So the male is normal and the female are normal. Maher and Sarah, both of them, they are normal. So normal crossed with normal, crossed with another female, which is the normal also. And then we move to the genotype. This is the genotype. So in the genotype, we have normal male. So this male is normal and the female is also normal, but they are heterozygous, meaning that they have the genotype N, A small, and then it crossed with N, A small. From where did I get N, A small? from the pedigree. They are normal, but they gave birth to an affected individual, albino Jack. So here the genotype is NA for both. Then we move to the gametes of the symbol gamma. So male and female, both of them they have NA. So let's work it here, and if you want, you can work it in percentage, and work you can say it in proportion according to the question. If I say to verify the phenotypic percentages, you have to work in percentage. Or if I say you have to work to verify the phenotypic proportion, you have to work in proportion. And since you don't like proportion, we're going to work it in proportion. Okay? So here we have N and we have A. So half and half. And also here we have N and A. Here we have half and half. So this is the genotype and the gametes. Here we move to the table of cross. In the table of cross, we have first of all to divide it into male and female. This is the first step you have to do it in the table of cross. This is male and female. What are the male gametes? They are M half, and they are the A, it's half. And here in the female also we have N, it's half, and in the second one we have A, which is half. So here if you want to work it NN, 1/2 times 1/2, it's 1/4. Sorry, NA, also it's 1/4. And also here we have NA, which is 1/4. And the last one, it's AA, it's 1/4. Here we move to the table of result. To move to the table of result, we have to write genotype and phenotype. Sure, all of them should be drawn using a pencil and a ruler. So genotype and phenotype. So genotype, we have NN, we don't have other than this NN, it's 1/4. While NA, we have two. We have this is NA and this is NA. So NA, it's 2/4, and it's meaning that it's 1/2, half. And finally, we have AA, it's 1/4. So here, both of them, they are NN, they are normal. So normal, half plus a quarter, it's 3/4, 3/4. And AA, it's affected, albino, it's 1/4. And this verified the results. Albino is 1/4. Therefore, results are verified. You have to write it. Why the results are verified? Since you have 4 children, three out of 4 they are normal. Fatima, Marie, and Ahmad. While one of them it's affected, which is the Jack, which is albino. So this is for the factorial analysis. And then let's move to the question of the homework. The opposite document represents the genealogical tree of a family whose members they are affected by the disease. No, we don't have the disease. We have dark brown hair and others having red hair. So one of them having dark brown and the other having red hair. So let's see here. Red hair is the one that is in black. Okay? In the black, they gave you the legend here. Red hair and the other, they have dark brown hair. So dark brown hair and red hair. Is the character red hair expressed uniquely in men? Justify. Look to the pedigree. If you look to the pedigree, we have generation 1, generation 2, generation 3. The one that having red hair, they are in the black. So here we have a male, female, sorry, here, and here we have a male. Also here we have a female, and here we have a male. Is the character red hair expressed uniquely in men, only in men? Justify your answer. What do you think about this, Muhammad Hassan? Is the red hair expressed only in men? Yes, Muhammad, what do you think? Okay, we can have Yusuf. Yes, Yusuf. What do you think about this?
شو اسمه استاذ wait انت عم تحكي عن اكس صح؟
X? What X?
wait شو can question again?
What the question is part A. Is the character red hair expressed uniquely in man? Justify your answer.
فكرت سؤال تاني sorry.
Okay, so if you have this one, pay attention here, Yusuf. Yes, Lee?
No, because 2, 1, and 3 are women and they have red hair.
That's it. So here we have not only the men are having the red hair, because here we have 1, 2, 1, which is a female having red hair, and 3, 3 it's a female having red hair. So it's not expressed uniquely in men. Part B. Is the allele responsible for the red character dominant or recessive? These are the black, they are for the red hair. If we want to move to this, yes, Muhammad.
أستاذ ودي
Yeah, start. Is the allele responsible for the red character dominant or recessive? Before you start, Muhammad, pay attention. If you said the dominant or recessive, you have to justify the answer for sure, but this justification is according to the pedigree. So you have to use the pedigree, okay?
Yeah.
Yeah, let's start.
It's recessive since yes,
First of all, before you answer, said 1, 1 and 1, 2. What do they have?
since 1, 1 and 1, 2 is
Have
normal
لا
and
مش
have
normal. No, wait a
normal
minute. No,
alleles
no, not normal يا محمد. They have
وان
what?
تحت
ما في عندي normal effect. عندي
have
dark brown hair.
dark
They
brown
have dark brown hair. Very good. But they gave birth.
okay, yeah. The allele responsible for the red hair is recessive since both parents had dark brown color hair, generation 1, and gave birth to 2 kids with red hair. So the red hair allele is masked by the dominant dark brown allele.
Okay, تمام. بس في كم terms محمد we have to substitute them. يعني أنت قلت لي the allele of the disease is recessive since the parents in the first generation they give birth to 2 kids. هون ما عادش نستعمل لا kids ولا babies ولا zygote ولا embryo. You have to say what? I have to say since 1, 1 and 1, 2 they have dark brown hair, but they gave birth to individuals 2, 1 and 2, 2 that have red hair. So the allele of the red hair is recessive. It was masked in the parents. It's recessive with respect to the allele for the dark brown, which is the dominant. So here you have to substitute the word kids. You have to substitute by individuals 1 and 2. And you have to say, instead of saying parents 1 and 2 in the first generation, you have to say 1, 1, which is this individual, Aida 1, 1, and this individual is called 1, 2. Okay, Muhammad? So this is related to the first part A and part 2. So part A, no, since both males and females, as shown in the pedigree, they have red hair, so it's not expressed uniquely in the males. Part B, 1, 1 and 1, 2, they have dark brown hair, but they gave birth to 2, 1 and 2, 2 that have red hair. So the red hair allele, it was masked in the parents, and it's recessive with respect to the dark brown hair allele, which is the dominant, or you can say simply with respect to the dominant dark brown hair allele. Symbols, dark brown in the dominant, I gave it D. بيجي for example هاني بيقول لي I don't want to give it D. Can I give it for example B capital? It's up to you. You can give it H capital. حب هاني يسميها مثل حرف اسمه. حب يسميها H capital. You can. حب يسميها محمد M capital. It's up to you. I don't have any problem, but you have to respect this. Meaning that if I use D capital here, all the question I have to use D capital for what? For the dark brown hair allele. I can't use D capital and in the third part or the fourth part I use it as D small or I use it as H capital. حبيت غير. This is not the case. If you change the symbol, meaning that you drop the exercise. You took the mark till here and down, you didn't get any of the marks. Meaning that you change the symbol, meaning that you change the allele, and you solve another exercise other than the one that is required. So you have to pay attention to this. Symbols cannot be changed every single minute or every single part. They have to be constant. So I gave D capital for the dark brown. I have to continue with the dark brown, D capital. R small for the recessive allele. I have to continue R small with the recessive allele, which is the red hair allele. Because if you continue with these, you have to use the same symbols. Otherwise, if you change the symbols, meaning that you change the whole exercise. So pay attention to this. This year and the next year, there is no mercy in such exercise in genetics. Either you solve it completely with complete answers and you have to follow the steps, or you're done. So one mistake, this simple mistake, it's going to drop the whole exercise. Drop the whole exercise after this part, for sure. So the first two parts, you get the mark, and part C, you get it. Part D, E, and F, for example, you're going to lose the mark. So pay attention to this. Because some of you, in the last quiz, what did they do? They use, for example, let's say we have dark brown and red. They use dark brown, the symbol D, and afterward they use the dark brown, the symbol D small. So they mix it. Sometimes they use a D capital, sometimes D small. It doesn't occur. Either the allele is dominant or it's recessive. It can't be dominant and recessive at the same time. Okay? So pay attention to this, please. Moving now to part D. Write the possible genotypes of the individuals 2-2 and individual 3-1. Let's start step by step. In this part, I'm going to solve all the genotypes of the individuals. All the genotypes in the whole pedigree. So step by step, and let's start with Cynthia. Cynthia, 1-1 and 1-2. They have dark brown or red hair.
They have both.
First all, they have dark hair or brown hair. Before we move to the genotypes, I'm talking about the phenotype only. They have dark brown or they have red.
Dark brown يا أستاذ.
Dark brown, thank you, Muhammad, but the question is for Cynthia. Okay, so Cynthia, dark brown or it's red?
It's red.
1-1 and 1-2. They have red?
1-1 and 1-2. I didn't listen to the question.
1-1 and 1-2.
It's brown, dark brown.
They have dark brown.
1-1, 1-2.
So sure they have the allele D, dark brown. And this one, sure they have the allele D, dark brown. Okay? Leave it. 2-1 and 2-2. What do you think, Yatala? Do you have dark brown or red?
Red.
Red. Allele of the disease of the red is dominant or recessive?
Recessive.
So they should be what? Homozygous or heterozygous?
Heterozygous.
Heterozygous. What is the genotype if they are heterozygous?
homozygous.
Yes,
قصدي homozygous. سوري قصدي أنا كان recessive.
Homozygous and recessive. They should be
Yes.
what? R small,
R small.
and this one R small
Same.
and R small. Also, if when I move to 3-2 and the 3-3, also they are the same. R small, and R small, and R small. So if I ask you the question, determine the genotypes or write the possible genotypes of the whole members of the pedigree, you can work 2-1, 2-2, 3-2, 3-3, all of them together. You can give them the same justification. Since they have the red hair and the red hair allele is recessive, so they should be homozygous of a genotype RR. So Mahdi, you are answering instead of Tala. Now your turn. 1-1 and 1-2, ya Mahdi. They have D, they are dark, but they gave birth to 2-1 and 2-2 that have red. So what do you think their genotype should be? 1-1 and 1-2. DD or DR?
DR.
Why?
لأنه أعطوا R.
Exactly. So each member will have RR. So each member of this will get R from the father and R from the mother. They should be DR. The KNODD, both of them. So all the individuals in the pedigree will have dark brown. Moving now to 2-3 and 2-4. Hani, what do you think? 2-3 and 2-4. They have dark or they have red? This is the first question.
They have dark.
Dark. So they have the allele akid, they have the allele D capital, both of them. But
Yes.
they gave birth to 3-2 and the 3-3 who have RR. So they should inherit R allele from each of her parents, or their parents. So they should be what? DR.
DR.
DR. Thank you. Moving to Nada. What do you think about 3-1? What is the genotype of the individual? 3-1.
3-1 في ياخد دي من بيرد ودي أو دي آر.
Exactly. It can be DD or it can be DR. Why? Because the dark is dominant and can be expressed in both. But dominant or recessive, it can be expressed in both homozygous or heterozygous. So here we calculated all, or determined all the possible genotypes for the whole members of the pedigree, even though they want us only for 2 members. They want only 2-2, which is this one, and they want 3-1, which is this one. But we determined the all possible genotypes for the whole family members. Okay? Let's move now to Joel. Joel part E. They said without doing factorial analysis. Without doing the factorial analysis. Explain how father 1-1 and mother 1-2, they have dark brown and they gave birth to son with red hair. Already we explained it. Can you explain it to me?
Yes.
Without factorial analysis, pay attention to this. So whenever I ask a question to determine the genotype, you don't have to do factorial analysis, even though you are not allowed to do factorial analysis. إذا قال لي determine the genotypes وأنا عملت factorial analysis لحتى طلعت الجينوتايب ما عملت لها explanation, meaning that your answer is not correct. Okay, Joel, your answer is?
Father 1-1 and mother 1-2
Yes.
gave birth to a son with red hair,
So,
since they have the
yeah.
2 alleles, the dark brown allele and the red allele,
Yes.
but the red recessive allele is masked
Very good.
by the dominant dark brown allele.
Very good. That's it. Very good. That's it. Okay. Thank you. Thank you, Joel. So here the explanation. So 2-2 has red hair, and the allele coding for the red hair is recessive. So it's only expressed in the homozygous state. Please, you have to know the way how to write these answers, because if you know the way, it will help you a lot. This way, it's almost the same. So 2-2 is red hair, so the red allele is recessive and can be expressed only in the homozygous, so the genotype is RR. 3-1 has dark brown, and the parent 2-3 and 2-4, they have dark brown, but they gave birth to 3-2 and the 3-3, they have red. So their genotype BRR, and they inherit R from each of their parents. So 3-1, it can be either homozygous or heterozygous. Homozygous DD or heterozygous of genotype DR. Last part E, without factorial analysis, 1-1 and 1-2, they have dark brown, but they gave birth, as Joel said, to individuals 2-1 and 2-2 that have red hair. And their genotype should be R small, R small. So they inherit the R allele from each of their parents, 1-1 and 1-2, that should be heterozygous, having the genotype DR. This is everything for this worksheet. Thank you.